So the name of that chapter was Flow of Control. When we talk about our programs and how our programs are running, a lot of times we describe it as a flow of your program or the flow of control of your program. And so what that means, the flow of control of our programs thus far has been just linear. Straight down, not skipping any lines. We execute each line as we come to it. Once we execute that line, we never come back up to that line of code. It executes and then it's done, right? The computer doesn't have to see it again. Then it goes on to the next line of code until it gets to the end, and then it ends. Okay, but it executes each line of code in order from the top to the bottom. Every single line gets executed. And that's just, a very simple program at first. Okay? But you could see how this isn't very intelligent the way that it's flowing. There's no decisions that are being made in this program. Okay? So we're going to introduce what's called a branch. It lets our program choose between two lines of code, or multiple lines of code, two blocks of code. The flow of control in any programming language inside of your computer, there's three things you can do in your computer, and only these three things. And every program out there in the whole world is created with these three flows of control. You can do something called statements, and like I said in that example right here, what we were writing were statements. Statements do something, they end, and they don't do it again. Okay, that's how we've been writing our code thus far. We've just written a whole bunch of statements. Statements always end with a semicolon. So if you see something ending with a semicolon, that's a statement. It does it, and then it's done. The second thing you can do inside of your program is a branch. Do something under this condition. Here's a picture of our first branch. Is this hard to read in the back? If we turn off the lights, would it be easier? Maybe for this slide presentation, we will. And then someone on that back wall, if you push that button up, it'll turn on the lights, and then you can turn off the light switch on the wall. Maybe this will be easier to read? Okay. Yeah, my slides for this one are kind of dark. Okay, here's an example of a branch. So we can either do something or we can do a branch. Our branch, I bet you can read this. Okay, it makes logical sense how it works. This is called an if statement. And what goes into the parentheses is called your Boolean statement, the Boolean part, meaning it's either true or false. Computers don't say, well, maybe it's true. No, they either say yes or no, true or false. There is no maybe in a computer. Okay? So it checks to see if x is equal to 10. Notice it has equal equals. Equal equals is our equality operator. Remember, one equal sign is our assignment operator, so we couldn't use that. So to check if two things are equal, we put two equal signs together, and that's our equality operator. It checks to see if what's on the right-hand side is equal to what's on the left-hand side. Okay? So we're just checking here. If x is equal to 10, then do this. Else, do that. So we've given our program a little bit of intelligence. We get to either do one statement or the other statement, not both of them. Okay? That's called our branching statement. It adds intelligence to our program because now it can make a decision based on that Boolean statement. And then the last thing for flow of control we'll get into next week and the week after are our loops. And loops allow us to repeat a line of code a certain number of times, or a certain block of code a certain number of times. And believe it or not, everything your computer can do are written with statements, branching, and loops, and that's it. All the logic for your computer are with statements, branching, and loops. So that means all your games like Halo, or I don't know, what's some other popular games nowadays? Destiny, my son loves. All those games, all the programs you have like Microsoft Office and Photoshop and everything on your computer are written with statements, branching, and loops. Okay? And then we throw an abstraction of object-oriented design, but the logic is still statements, branching, and loops. Okay? So kind of gives you that picture of, hey, if I want to learn programming, you just have to learn what statements, branching, and loops do, and then you can write any kind of logic for your computer or any type of program. All right, so this week on branches. So we looked at that one branch in that sample slide there and that slide above. But pretty much our branches look like this, or a deviation of this. If the Boolean expression is true, do statement 1, otherwise do statement 2. And many textbooks and online tutorials will analogize a branch like you come to a fork in the road, and you either take the left path or the right path. You can't take both paths at once. So you can only go one way at a fork in the road. You can only take one branch. Okay, so that's what that little picture is. All right, here's an example. What if we wanted to calculate hourly wages? And actually, we're going to write a program very similar to this today. There are two choices. Let's say we're writing a program to calculate our employees' hourly wages, right? So you have your regular time pay, which is your rate times your hours, up to 40 hours. And then anything over 40 hours, you want to get time and a half. So it's your rate times your 40 hours plus 1.5 times your rate, the number of hours that are above 40 hours. Do you see how we made that little equation there? Okay. So the program must choose which of these expressions to use. So if it's less than 40 hours, then we just do rate times hours. If it's greater than 40 hours, then we do the other. Notice if it was under 40 hours, if we did the second equation, you would actually get negative pay, and then that would be bad. So we don't want to do, that equation all the time. We only want to do if they get over 40 hours. We don't want to subtract from their pay. Otherwise, we'll have a lot of employees quitting on us. So, okay. So we need to design our branch. So we need to figure out our Boolean check will be, hey, if the hours are greater than 40, then use this equation. Otherwise, use the other equation, which is just rate times hours. So we kind of know what our Boolean check is going to be. Okay. So here's how we would write it inside of our programming language. So we say something like this. If the hours is greater than 40, then our gross pay is assigned the value of rate times 40 plus 1.5 times rate times hours minus 40. Otherwise, our gross pay equals rate times our hours. I think the important thing to note here, too, and one of the things that a lot of beginning programmers get wrong is they try to put a semicolon after our branches. Okay? So remember that branches don't have semicolons on them. Only statements do. Okay, so no semicolons after your if statements. All right. You can write, so let's look at the different ways that you can write these things. What if you didn't have an else part? What if you only wanted to check if something was true, and if it's true, you wanted to do something, if it's false, you don't care. Right? You don't want to do anything. So you can write an if statement without the else part. You don't necessarily have to have the else part. Notice that you can't write an else part without an if, though. That doesn't make sense. But you can have an if part without an else. Right. In this example here, I said, hey, if weight is greater than your ideal weight, then you need to start subtracting calories. But if it's less than, then you're fine. You don't have to do anything. So we just left it. Okay? So you can have an if without an else. What if you wanted to choose in between three pathways or multiple pathways, right? You wanted to choose, make a decision, and such as grades. Okay, that's a programming problem they have probably in every single textbook in here is to calculate grades. They like that to be a student programming problem, is calculating your grades. Okay, so here's an example here. So if our character, this is a character, right? I can tell it's a character. That's not a very good variable name, by the way. That's a horrible variable name. But if it's equal to the character A, then we up the number or the count of our grades by 1. A grades increase by 1. Else, if our character equals a B, we up the B grade count. Otherwise, we up the so-so B grade count. Yeah. But the important thing is here, we have the if, and then a Boolean statement, else if, the Boolean statement, and then our else part. Now, we could leave the else part off here, too. Okay? So you don't necessarily have to have the else here either. And you can have multiple else ifs. You can have as many as you want. You can have 100 of those if you want. And this is actually an efficient way to write code because once it finds one true branch, so if the ch equals A, it doesn't check any more of the else ifs. It'll say, hey, this is true, and then it goes down here and it skips all the rest of the else ifs. So using else if in your code rather than just a whole bunch of if statements, if they are related, you should use else if. That way it's more efficient. So once it finds a true path, it can skip all the rest of the paths. Okay? All right. Now you can use break and continue statements. They aren't used a lot in programming, but you can. What a break statement does is it breaks you out of a loop. And then a continue statement continues you in that loop. So can you use a break and continue inside of a branch? Yeah, if you use a break in a branch, it'll break you out of the branch. I don't know. I guess it doesn't make sense for branches all that much. And then a continue, I guess would break you out of the branch too. All right. Here are comparison operators. There are only 6 of them, just like, because there are only 6 exist in the world, right? So you can check if something's equal to something or if something's not equal to something. If something's greater than or equal, less than or equal to. And so this is how we write them in math. This is how we write them in plain old English. And then this is how we write them in C++. Our most programming languages. A lot of programming languages use the same symbols to represent these comparison operators. Actually, in JavaScript, they have equal, equal, and equal, equal, equal. 3 equals in a row. So equal, equal checks to see if something's equal to something else. Notice what's on the left-hand side. This guy answer better be a character, right? If I'm checking to see if it's equal to this character. Not equal to is an exclamation point and the equal sign together. Greater than or equal to together, 2 symbols together. And less than are equal to. And just remember, you can't have white space in between these 2 symbols because they are considered one symbol together, or one operator together. Okay, so you can't have white space in between those guys. All right. We have a couple more operators that we can use. We have what's called the AND operation. The AND operation checks to see if 2 Boolean statements are both true. Okay, so with the AND operation, we write it with the ampersand, ampersand. And let me look for we have the OR operation, which checks to see if at least one of them is true. I'm looking for my truth table, and I don't have a truth table in here. Okay, so here's how our AND operation works. So when you're looking at a truth table is actually the AND is the basis of all computers. These truth tables are the basis of all computing and how digital circuits work and all computers, right? So of course we have incorporated them into programming languages. Okay. Whenever you see a 0, that means false, usually. And whenever you see a 1, that means true. And so our inputs would be the first Boolean operation and the second Boolean statement. So if both Boolean statements are false, then we get false. The only time that we are going to get a true is if both Boolean statements are true. Okay? So let's take a look at that example here. I have an example on this slide. So in our example, we have one Boolean statement. Notice a Boolean statement with the comparison operator. And then a second Boolean statement. And then those Boolean statements are connected with the AND operation. So this is like input 1 and input 2. So if x was equal to, what would make that Boolean statement true? What would x have to be? I heard 5. 5 would make it true. What other values? What are all the values? What's the range of values that would make that true? Anything greater than 2 and less than 7. So notice it's an AND operation, so they both have to be true. So the values x could be to make that true would be 3, 4, 5, 6. Notice that if it was 2, it would be false because 2 is not greater than 2. And if it was 7, it would be false because 7 is not less than 7. If you wanted to count 7 and make it also true, you'd put less than or equal to here. So any other values of x would make that false because with the AND operator, they both have to be true in order for it to be true. Okay? And again, the AND operator is ampersand, ampersand together with no white space in the middle. And you can actually write it without these parentheses. I over-parenthesize this to try to make it clearer. But you don't need the second pair of parentheses. You do need the outer parentheses for the if statement, but you don't need these inner ones. But you can write them. It doesn't hurt. All right, OR operation, the same thing. Let's look at our OR table. Oh, I put AND OR table. Here's our OR. So this is our first Boolean statement, second Boolean statement, and whether it's true or false. So notice that with an OR, only one of them has to be true, and it'll make the whole Boolean statement true. The only time it's false is if all of your Boolean statements are false, then it will produce a false output. Okay? So the OR operator is written with a line and a line. And you might say, well, where's the line on my keyboard? And it is slightly confusing at first. But it's underneath the backspace key. There is the backslash. And then above it, there's a line. And it looks like there's a hole in between it. And then another line on top. When you type that line, it actually makes that line and that line together. Okay, so it's two of those lines together make your OR operator. So for example, here's our example. We're checking to see if x is equal to 1 or x is equal to y. And I did put a white space in here to kind of write it clearer, but you don't really put the white space in there. Okay. So if x contains 1, then it would be true. It might not necessarily be equal to y, but as long as one of those is true, we're okay. So if x is equal to 1, then hey, the whole thing's true. If x contains the same value as y, hey, it makes it true. If x is anything else, then it's false. Okay. Another thing about our Boolean statements, and I probably have this in another slide. Let's say x is equal to 1. The way your computer executes this is if it says, hey, you plug it in, 1 equals 1, it sees that this is true, it doesn't even bother checking the rest. Because it knows, the compiler is trying to be efficient. Once it reaches one true value in your OR statement, it won't check the rest of your ORs. And notice in this one it only has 2, but you could have a whole bunch of Boolean statements connected with OR. If I wanted to check if x is equal to 1, 2, or 3, I could x equals 1, or x equals 2, or x equals 3. You could have a whole bunch of OR statements in there. All connected with the line in between each Boolean statement. So notice that the line, or the OR operator, goes in between each separate Boolean statement. Okay? Okay, the NOT operator is probably the easiest one. It makes true false and false true. It just switches it. Okay, so if I put the not operator on the outside of a Boolean statement, if this was true, it then makes it false, and if it was false, it makes it true. It switches it. Okay. So true if x is not less than y, and this is true if x is not equal to y. So the exclamation operator can make expressions difficult to understand, so use only when appropriate. All right. Now in math, we can write things like x is less than y is less than z, something like that. But remember, in a computer is binary, and it can only see two things at once. This is one of the main limitations in a lot of algorithms in a computer, especially sorting algorithms, is its ability to only compare one item to another item and not to everything else. It only can compare two items at once, or two entities, or two elements, two values at once. Okay, it can only compare two things at once. So if I wanted to write something like this in my computer, I would translate this logic. I would have to take this and make it one Boolean statement, take this, make it another Boolean statement, as you can see right here, and then connect it with the AND operator. Okay, so you can only use that comparison operator with one thing on one side, one thing on the other, so two things at once. And then you would connect it with that AND operator. Okay, don't ever write things like this. This is not right. Your computer would get completely baffled and not be able to compile. Okay, so that's how we translate our logic of something like that to a computer. So actually your book goes into this. One of the main things we always have problems with is putting semicolons after if statements, but sometimes we forget the equal equals and we'll just put the assignment operator instead of an equal equal sign, and your code will compile and it will run and it will have a horrible logic error. So what happens when you write something like this, it goes if, and then it assigns 3 into x, and that comes back as true because it's true that it did that. Actually, it's not 0, so it's good. It comes back as true, and then, it does whatever the if statement's true. And it's not checking to see if x is equal to 3, it's just assigning the value of 3 to x. And so that's one of those things, if your program's not working right, check if there's a semicolon, and then check to see if your equal equals operators are not just assignment statements. Okay, because that happens a lot. Now, what if you wanted to do multiple things if something was true? So if something is true, you want to do like a whole bunch of multiplications or do something like a few different things. If you want to do more than one statement after an if statement, you enclose those statements into a block of code with curly brackets. So you do your beginning curly bracket and your ending curly bracket, and this sees it as a block of code. So then if this is true, it'll execute this whole block of code. So it doesn't execute just one line. It'll execute everything in that block of code. So here's our example. We'll look at an example of this one in a second. But pretty much you just have your statements. You can even have other if statements, embedded if statements. You could have loops. And it's a combination of these things that make programs do what they do. All right. Now this kind of deviates from our branching today. But when I made these slides, our lab incorporated this into, we had to know what CC type, so it's good to go over this anyway. But CC type character functions are functions that we can do on characters. Remember how before we discussed all the math functions, and we looked at CMath, and we saw the POW function, and the average function, and the round function, the ceiling function, remember that one, and the floor function? Okay. So these are functions that have to do with characters. Okay. So we can check to see if something is a numeric character or an alphabetic character. If something's a digit, see if it's a control character. See if a character is lowercase or see if it's uppercase. See if it's the white space character. Okay. So note that we do have those functions, and we'll use these functions in labs in the future, of course, right? All right. So let's look at this example here. So these functions, you might notice, actually in here it doesn't show what they return. But most functions that have something written like this, like is lower, like it's asking a question, is lower, they return a value of true or false. So a lot of times you can use these functions that return true or false inside of an if statement. Because this function is going to return true or false. So let's say I had this written code. This is good code to look at. We have a character. Here's our variable. We named him CH, not a very good name. Remember that this is called our declaration. And then we initialized him to the capital letter A. And note when we initialize characters, we use single apostrophes, not double quotes. Double quotes are for strings. So now we're going to use this function, and we put it right inside of our if statement. We say if, and then we have our parentheses for our if statement. And we put that function call right in those parentheses, and we write the function. We put is alpha, and we give it an argument of our character. So that function is going to return true if it's an alphabetic character, and false if it wasn't an alphabetic character. Alphabet character means in the alphabet A through Z. Okay. And then this function here in our else if statement checks to see if our character is white space. It returns true if it's white space and false if it's not. So a lot of times people will put functions right in the parentheses in the Boolean part because they do return the value true or the value false. So they make that if statement work. So if it's true, it does this line of code. Otherwise, it checks this. Now if it's true and it does this line of code, remember what happens. If it's true, it executes this line of code and then skips all the other else ifs. Okay. Now if this is false, it goes and it skips this line of code because remember it only executes that if it's true. So if it's false, it'll come here, check if this is true. If this is true, it executes this. But if it's false, then it goes on. So with the value of letter A, it'll only execute this line of code. It'll up our chars by plus plus. So chars is probably an int, and it increased it by 1. Remember, plus plus increases a number by 1. All right. So we have if else, we have if else if, we have if else if else, and then we have switch. Okay, so switch is our other type of branch. And switch does look different than our other, if else ifs. But it is a branch. Okay. It does, in essence, the same thing. Anything that you write in a switch, you can write with an if else if. And anything you can write with an if else if, you can write with a switch. Some if else ifs don't translate well to switch statements. They'll be really long, especially if you're checking a range of numbers. But you can always convert one to the other and back and forth. Okay, so it is programmer preference, and what looks cleaner is if you choose an if else if or a switch statement. Okay. Well, here's how switch statements work. You just have to remember a few rules with switch statements. The first rule with a switch statement is you can use a switch statement to check the value of an integer or a character or a string, but not with doubles or fractional numbers. You cannot use a switch statement to check fractional numbers. All right, maybe I should go over how it works first here. So switch, it's actually pretty easy to understand. We have the word switch, that's our key word. And then we have parentheses, but what goes in the parentheses is not a Boolean statement. What goes in the parentheses is either an integer or a character, usually. Now, what goes in the parentheses is what we're going to compare down here. So we're pretty much checking to see if something is equal to something else. So you have the word switch, our keyword. Then we have the word case, which is also keywords. and default is a keyword. Okay? So we'll have case, and then the value that we're comparing what's in here to. So we're comparing choice to see if it equals 1, choice to see if it equals 2, choice to see if it equals 3, and if it doesn't equal 1, 2, or 3, then we do what's here in the default. Now in this example, choice is equal to 1, so if we plug 1 in, it'll go here and say case 1. Ding, 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 right? It'll say it's true. It'll execute what's inside of case 1. Now in this example, we only have 1 line of code, but you can have many lines of code. And it's going to keep on executing until it hits a break statement, and when you get to the break statement, you jump out of your switch and continue on in your program. Okay? So this is kind of the weird thing that switches do. What if I change this 1 to a 2? Okay? So if choice were equal to 2, go to case 1 and go false. Go to case 2, it would be true. No, it doesn't check it, it just doesn't see it anymore. So what it does when it says true, it executes this line of code and prints out it's a 2. But because I forgot my break, it'll also print out it's a 3. And then when it hits the break, it jumps out of here. And you might think, well, why did they do it like that? But we can use this to our advantage sometimes, like leave out the breaks on purpose if we want to execute more than one thing for a value. Okay? And then another thing, too, is your values do not have to be in order. I could have put 3, 2, 1. They don't have to be in any kind of logical order. I could have put 2, 1, 3. So the important things to remember about switch, you can use them with integers or characters. If you don't put a break, then remember it keeps executing inside of that switch till it hits a break, ignoring the other cases. And then if it doesn't match any of the cases inside of your switch, because you could have 100 cases in here, but we only have 3. If it doesn't match any of your cases, then it goes to the default and prints that out. No, you don't have to have the default, actually. That's a good question. That's the last thing you need to know, is you don't necessarily have to have the default. A lot of programmers will say, hey, yes, you should always put a default, because what if it does come back as something that's not listed in your cases? Okay, but if you leave the default out, it will still compile and run. Okay? All right, switches are nice for like menu systems, you know, or when your value of your variable can only be a certain thing and you know exactly what you want to do. Switches are nice and neat and easy to read. They're hard to get wrong. Okay, so a lot of people will choose a switch statement to write like a menu system or something inside of a computer. Okay. All right, so here's our conclusions. And actually, I incorporated these conclusions into your lab. You guys are going to write an if-else statement that outputs the word high if the value of the variable score is greater than a certain number, and low if the value of score is at most 100. Okay. Or writing an if-else statement that outputs the word warning, provided that either the value of the variable temperature is greater than or equal to 100, or the variable pressure is greater than or equal to 200, or both. All right. But I did incorporate these questions in your lab this week. All right, and that's our slides on branching. That's all you need to know about branching, right? All right, actually, is there any questions on branching? Otherwise, we're going to dive right in and just make a program with our branching that I posted. Actually, it's a salary program. All right. So I thought we could practice today, and by doing a programming problem from your book, which is a typical kind of branching problem here. And I went ahead and I took a picture of it and posted it here. So let's say an employee is paid at a rate of $16.78 per hour for the first 40 hours worked in a week. And then any hours over that are paid at the overtime rate of 1.5 times that. So sort of like the examples in the slide, right? From the worker's gross pay, okay, so we're going to program the first part, and then we'll program the second part. Now, when you read a programming problem like this, it might seem, oh my gosh, we want so much stuff. But remember that you can break down the parts and program each part separately, make sure it works, and then it's not so overwhelming. All right. The second part of this programming problem says, from the worker's gross pay, 6% is withheld for Social Security tax, 14% is withheld for federal income tax, 5% is withheld for federal or for state income tax, and $10 per week is withheld for union dues. Is that usually the way? Yes. If the worker has 3 or more dependents, then an additional $35 is withheld to cover the extra cost of health insurance beyond what the employer pays. I think it's more like $350, not $35, but that's okay. Write a program that will read in the number of hours worked in a week and the number of dependents as input. So notice that usually in these programming problems, they tell us our input. And will then output the worker's gross pay, each withholding amount, and the net take-home pay for the week. All right. And then it says for a harder version, write your program so you can do it over and over again. Okay. And we can do that if we want. All right. So I'm going to have you guys kind of write with me today. And we'll go nice and slow. But we are going to complete this problem and then turn him in today. Okay? So remember that the first part of this problem says an employee is paid at a rate of $16.78 per hour for the first 40 hours worked in a week. And then overtime hours are time and a half. So we're going to implement that first branch first. Okay? So like I said before, when you're doing a programming problem, don't worry too much about all of it. Just do one step at a time, get it to work, and then continue on to the next step. So remember to put your name at the top today. And today's date. And this is programming problem from chapter 2. I think it's from chapter 2, number 6. This will be chapter 2, programming problem 6. Now, hopefully you're getting good at copying and pasting from your old programs. But the beginning of our programs, hopefully you've noticed by now, all look the same. All right. The beginning of our programs in here will always all look the same, except for maybe we'll include some more libraries later on. But we'll always just declare our namespace out here. We always start with int main in our curly brackets. All right. And so remember, last week we went over variables a whole bunch. So if we all understand our variables. And so at the beginning of our program is where we declare and initialize all the variables we're going to use. Right? And so what variables will we have? Well, you go and you look at the programming problem and you decide what kind of variables that you'll need. And remember, if you forget some or you get it wrong, you can always go back and change them. But pretty much you start here and you decide what variables you want. So before I even start writing them, what would be a variable? Anyone? Hourly wage. That's a great variable name even. Just name it hourly wage. And then what type should he be? Type means what should I declare him as? Double. Very good. Because he has a decimal place. And hopefully that was very apparent to everybody. At this point in the class, that should have been apparent to you. That, hey, I'm going to declare him a type double. And then what should I initialize him to? Good, yes. Okay. So it is a good idea to initialize him to that because that's not going to change. Sorry, I can't hardly hear. Oh, yes, very good question. Now it is money, but what if I did put the money sign right here? Yeah, the computer gets confused because he sees that as a character and not as a number. So we are going to remember that it's money, but we're not going to program it as money. So we as programmers will remember that we're going to have the dollar sign on the output, but you don't want to put it into that variable because that variable can only hold numbers. It can only hold a decimal number. So it can hold the integer part of the number and the decimal part of the number. But good question. Okay. So we have 16%, 78. Now we're going to have to take in two inputs. We're going to have to take in the input of how many hours they work and how many dependents. But let's just worry about how many hours they worked first. So we're going to need a variable to hold that input from our user. So we can call it like hours worked or something. Now is hours worked good as a double, or should we make it an integer? Can you have a decimal or part of an hour that you worked? Yes. What if they worked 15 minutes, then they'd have to put 0.25, quarter of an hour. Or if they worked a half an hour, they'd put 0.5. Okay, so yeah, double makes sense to do hours worked as a double. Right. So we'll just worry about the beginning of this programming problem first. We'll worry about all the whole dependent Social Security stuff after, right? We just want to get their normal wage first and calculate it. All right. So we declare our variables. Then we'll do our input, our processing, and our output. So first things first, we get our input from the user. Okay. Now normally when we get input from the user, we like to have some kind of output to tell the user what to input, plus it kind of prompts us to type something in. Okay. So we could say, please enter in the number of hours you worked. Now remember, I don't mind if you write something different than what I wrote and be creative, but you should do some kind of output that prompts the user to enter in the number of hours. And then you can input your hours worked. So remember how your CN statement works. It'll be expecting a double, and so when we type in a double at the keyboard, it'll take in that double and place it into this variable. All right, now we get to have our processing. So that was our input. Here's our processing. Our processing is going to incorporate that logic that we need. Yes, Alexander?
At the end of cout, does it matter if the end L?
No, I didn't bother putting an end L, but you can. I ran out of space. So now remember, if I don't put an end L, it is going to be smack dab against.
Yeah.
I could do something like colon and then have them type it right next to it. Because remember, end L lets us skip a line. So very observant. I didn't put an end L here. So it's not going to skip a line, so they'll type in their hours right next to that, which is fine. You could put an end L here. Remember how you put end L in there. Okay, for our processing, this is where we get to do our logic, our branch. So of course we're going to make our if statement, and whenever you have an if statement, you have your parentheses. And what goes in the parentheses is our Boolean part of our if statement. Okay. So we're going to check if hours worked is greater than 40. Alternatively, we can check if hours worked is less than 40, and our program would still produce the same output if we programmed it right. So should we do less than or greater than 40? Wait, we'll do greater than. We'll do greater than, and then I'll also write it less than or equal to. Because remember that if it was less than 40, we would actually want to write it less than or equal to 40. Otherwise, we leave out, if they typed 40 in there, then it wouldn't execute the right thing. All right, so greater than 40, what do we want to do? We'll say something like our gross pay is going to equal our hours worked Wait, so let's see here. So for the first 40 hours worked, we're going to get our normal pay, our hourly wage, and then for over the 40 hours, we'll get time and a half. Okay? So if it's greater than 40, I know that they worked at least 40 hours. So I'm going to say you're going to get your hourly wage times those 40 hours you worked. And then we'll add in your hourly wage times your 1.5. So then you get pay and a half. So how much would pay and a half be? That would be 8.39 extra. So then that would be just so we know, it'd be $16.78 plus the $8.39. So they're going to get $25.17 an hour when they work time and a half. So then we want to multiply that by the hours worked minus 40. Because we don't want to give them all their hours worked again, then we would end up in debt. Minus 40. So it is kind of a longer equation. So our hourly wage times 40 plus our hourly wage times 1.5 times the hours worked minus 40. Technically, I don't even need these parentheses either, but I do need these last parentheses because of order of operations. So whenever you're writing equations like this, always double check your order of operations, meaning just do it in your head real quick. It'll do the multiplication. Actually, it'll do what's in the parentheses first. So it'll do this first. Well, actually, it'll do this first. This second. It'll do this third. This fourth. This multiplication fourth right here. And then the addition last. So whenever you're writing these equations, just make sure you know you're doing your correct order of operations and put parentheses in. All right. Looks like most people stopped typing. So then, of course, we have our else part, because if they didn't work over 40 hours, we still want to pay them. So we still want to give them their gross pay. And so if they worked less than 40 hours, it'll be their gross pay times their hours worked. Because if they worked 30 hours, it would just be their hourly wage times 30. If they worked 5 hours, hourly wage times 5. That makes sense what we did, right? Now, one thing we forgot to do is we forgot to declare this guy. I know I needed him, I just didn't declare him. So I would double-click Control-C. And then should we declare him a double or an int? Gross pay should be a double or an int? Double. Very good, yes, because it's definitely probably going to have decimal places in there. So just make sure you declare him at the top. Notice I only initialized one of our variables at the top, but hours worked gets initialized here, and gross pay got initialized here. You see how the other two variables got initialized in our program. So we did our input, we got our processing. Guess what's last? Everyone together. Our output. Good. Wait, question?
Yes. After the if statement, do you need curly brackets or?
Good question. Now, if I'm only executing one line of code after an if statement, you have the option of leaving the curly brackets off. If you are executing anything more than one line of code, you have to put the curly brackets on. So curly brackets in this case are optional because it's only one line of code. But if you wanted to put curly brackets, you would put one here like that, or on its own line. Remember I said you could put it on its own line at the beginning of class. If you were writing it the Java standards way, they make their curly brackets look like this with if-elses. So just note to self, this curly bracket matches this one, and this curly bracket matches this one. If you're doing it the way that your book has, you would put curly brackets on one line, else statement on one line, curly brackets on the second line. So all three of those ways are acceptable ways to write your program. Now if I did put them all up like this, let's say I had it like this. Note that my main has it down here. Remember I said to be consistent? I'd want to be consistent. Okay, so just note to self. Now, does it look better with curly brackets or without? I don't know. I'm used to seeing the one line of code looks like this, so I'd probably leave it like this, to tell you the truth. All right. Just because it's easier to read. All right, now we're doing our output. So we'll do our cout, and we'll say something like your gross pay is, and then put our gross pay in there. Now if you want that dollar sign to pop up, remember how we said it'd be cool if we had a dollar sign? We can put the dollar sign inside of the quotation marks because the dollar sign is a character. And remember, your string is composed of characters. Remember, strings have the double quotes. This is your string. So we put that in there. Now, I can kind of foresee that we're going to get more than 2 decimal places a lot of times, and we could do some tricks to get rid of it and make sure it looks like money with 2 decimal places. But we should just check this anyway. Check it first. So remember that when you write your code, when you're writing it at home and you're doing these programming problems, program one part of the problem. Don't try to program the whole problem at once. That's a bad idea, usually, especially your first programming. Usually you'll program part of it, make sure that this part works first, and then go to the next part. Okay, so if I were to run this thing, remember that we have to save it. And let's say I worked 1 hour, I should get $16.78. If I work a couple hours, let's say I work 40 hours, is that the correct number? 671? Of course, you'd have to check yourself. You remember when you're making these programming problems and you're typing in your input? I'm pretty sure it's the right answer, but you always kind of check it. Notice it says $671.2. This is when we need that decimal place to force it to 2 decimal places. Okay. And then if we do more than 40, let's say we do 41 hours then, I should get time and a half for that last hour, and I did. So we can see that our branches are indeed working. So just kind of review, remember that if this is true, it executes this line of code, and if this is false, then it just executes this line of code. All right, now what if we only want 2 decimal places? I guess we can fix that first. We're going to use something called set precision. I think I wrote it wrong. And they go over this in your book. But what you have to do is you have to include this library called the I/O, or Input-Output Manipulation, I/O manip library. It lets us use this function called set precision. In the IO library, then we would set the precision to 5, or actually us to 2, and that means it'll force it to have 2 decimal places. So in this example online, notice that they set it to 5 decimal places, to 9 decimal places. And in your book, do you guys remember what page on your book it's in? Chapter 2. Yeah, they write it a little bit different. Notice that they don't put the using namespace STD, so that's why they write their cout statements like this. In order for us not to write our cout statements that look like this, we put at the top of our programs using namespace STD, and that's what allows us not having to write the STD : cout stuff. That's why we put that line of code up there for ourselves, to make it easier to read, so we don't have to put all that stuff. Okay.